Okay, so there is a chart that we had kind of talked about that if you have an even or an odd function, you would look at the leading coefficient and you would say if it is greater than 0, it does one thing, and if it's less than 0, it does something else. So if the function was even and it's greater than 0, they would be facing the same way. They would both be facing up as the end behavior. If it's even and it's less than 0 or negative, they would both be facing down. If it's odd, then and if it's odd and greater than 0, it's going to be going up or increasing. If it's negative and odd, it's going to be going down. So what does that mean? Remember that you always want to pick your leading coefficient. So the highest power exponent on an x that you see. And it's not always the first one. It is here, but okay, so this 6 right here is even. So that's where we're getting even from. This negative pi, remember pi is just 3.14 and a decimal that keeps going forever. But that's all that pi is. And you're trying to figure out, is that number positive or negative? It's negative, right? So we're looking for something that is even and negative. So even and negative is going to be this one that's facing down. So which one is the correct answer? B. Because we want the one that is even, because 6 is even, but it's facing down. Both of the points are, the ends are facing down. And then because it's negative, it's less than 0. It's going to be this one. Okay, be careful about this one. Which one is your leading coefficient? Or leading term, rather? You want the highest power, you're absolutely right. You want the highest power exponent on your x, which is going to be x to the 7th. 7 is odd. The leading coefficient here is positive. It is greater than 0. 0.7 is greater than 0. So we're looking for odd, so down here, and positive, which is greater than 0. So it would need to look like this one. It needs to start pointing down and then be increasing, getting bigger. So, A, are you guys okay with that? Okay, so that kind of reminds you how to do that even and odd and leading coefficient stuff. Okay. Questions about any of that? Number 3, bless you. Find the zeros of the polynomial function and state the multiplicity of each. And this one is a little bit tricky because we can actually keep factoring this in here because this is the difference of squares, x squared minus 16. So there's a couple of ways I knew that. One way I knew it is because it had an x squared. Usually you're used to seeing something like x minus 3. It's never an x squared in there. So you could do your quad program and see if you can factor it anymore. But I do know that's the difference of squares. So this means that this is x minus 4 times x plus 4. And I have it, both of those are 3 to the 3rd power. So the next thing I know that is the 0, if it factored is negative 4, then the 0 is positive 4. And the multiplicity here would be 3 because it's raised to the 3rd power. This 0 is negative 4 because it's always the opposite of whatever is in here. And its multiplicity is whatever the exponent is, so to the 3rd power. So C would be the right answer here. Positive 4 and negative 4, each with a multiplicity of 3. Okay, so it's asking for me to find the zeros and to list the multiplicity of each of these things. Negative 6 would be the first thing I look at, but negative 6 doesn't have an x in it, so I don't have to worry about it. Okay, the next one I'm going to look at is x minus 3 squared. That has an x in it, x plus 1 to the 4th. That has an x in it, and x to the 3rd. So remember that the zeros are opposite of whatever's in here. So if the factor is x minus 3, the 0 is going to be 3. And that 3 has a multiplicity of 2 because that's what the exponent is. X plus 1, the opposite of plus 1 is going to be minus 1 with a multiplicity of 4. Okay, and remember that you could write this as x minus 0 to the 3rd. So that is a 0 is your multiplicity. I'm sorry, 0 is your 0 with a multiplicity of 3. Okay, so we would say the 0, 3 has a multiplicity of 2. Negative 1 is a 0 with a multiplicity of 4. And the remaining 0 is 0, and it has a multiplicity of 3. Really quick. If your multiplicity is even, does it cross the x-axis or does it bounce, which we call as tangent to the x-axis? If it's even, does it bounce? Does it go across or does it bounce? Close. The other option. So if it's even, it bounces, it's tangent. So this one's going to bounce. This one's going to bounce because 4 is even. This one at 0 is going to cross over the x-axis because the multiplicity is odd. And just reminding you about that. We'll have some more problems about that here in a little bit. Even is going to be tangent to the x-axis, which means it bounces. And if it has an odd multiplicity, it's going to cross over. Okay. Number 5, our goal is to get to 10 today. Find the zeros of the functions and their multiplicities. So this is an x to the 3rd. So we talked today, how do you find zeros? Can't use the quad program on this one because it's what? It's x to the 3rd. So we could use the polyroot finder, right? We could use the app, the polyroot finder, and see if that will get us started. On this one, when we use that polyroot finder, so I would go to apps, go down to Poly Simulator 2, hit enter, and we would start. We would have to pick that. It's the highest power is the 3rd. We would hit next, and we would type this thing in, and hopefully we can get some answers here. So 1x to the 3rd minus 7x squared minus x. So we have at least 1x and then plus 7. Okay, so I could hit solve and it's going to tell me hopefully some answers. And this time it was nice because I don't have any imaginary or irrational. It's just 7, -1, and 1. So really on that problem, I'm done. It's 7, -1, and 1. Each 0 has a multiplicity of, remember that our highest power of exponent is a 3, which means that at the most I can just have 3 zeros, and I have 3, so that these can't be listed more than once a piece. So they just will be listed as 1 time a piece. Okay, because it's an x to the 3rd, and I have 3 of those. Okay, determine whether this following statement is true. So let's just talk about this. X minus 6 to the 10th. We just got through talking about this a while ago. If this is even, then it is going to bounce. And we call that tangent when that happens, when it bounces on the x-axis. So the 0, x is equal to 6. It's going to be tangent there. It's going to bounce across it because the multiplicity is even. On this one, x plus 3 to the 7th, well, that is odd. So it is going to cross the x-axis there when our 0 is -3. Okay, because it's odd. So which one of those things are correct? The statement is true. Well, let's read the rest of the statement. I'm sorry. The graph of the polynomial function crosses the x-axis at 6, 0. Well, no, we said it's, so we know it's false. It doesn't cross the x-axis. It's tangent there. So it's not true. So it's not this one. And it's not this one. It's not true. The statement is false because x minus 6 to the 10th is a factor of the given polynomial. That's true. And the exponent 10 is even. That's true. Thus, the graph is tangent at that point. We okay with that? Okay, this right here is wrong because 0, 6 is not a 0. That would be where it crosses the y-axis. See, the point 0.06 crosses the y-axis, not the x-axis. That's a y-intercept, not x-intercept. Okay. This one's pretty easy. We're supposed to answer. We're supposed to go and circle the leading coefficient, the leading term, and the leading term is the one with the highest power exponent on the x, so it would be negative x to the third, which means negative 1x to the third. So that means it has a maximum of 3 real zeros. It has to be whatever the exponent is, the highest power exponent. And that means it could have a maximum of 3 x-intercepts. And when you do the turning points, you subtract 1, 3 minus 1 to get 2 turning points. Okay. On number 8, sketch the graph of the polynomial function. I feel like the majority of students are going to go straight to the graphing calculator and they're going to type in that function. And that's okay. But if you look at your graphs here, this graph, every one of these graphs goes from -10 to +10. That's usually what our graphing calculators are set at. That would be your x minimum and this would be your x maximum. This -100, that is not what your graphing calculator is set at. This +100 is not what your graphing calculator is set at. So if you want your graphing calculator to really help you with this one, then you've got to change your window, and I'll show you how to do that in just a minute. But what we do know about this problem is that we are supposed to, well, first off, our leading coefficient is positive, so it should be either increasing or facing up. The next thing we know is we've got zeros at 0 because x is equal to 0. Right here, what would x minus 3, what would that 0 be at? X minus 3 has a 0 at what? +3, right? It's always the opposite of what's there. X plus 3 has a 0 at -3, and x minus 6 has a 0 at 6. So one thing I do know is if it doesn't touch 0, 3, -3, and 6 on the x-axis, that's a problem. So we could blow this thing up and look at it. But this looks like 6, 3, 0, -3. That one maybe is it. This one is -3, 0, 3, and 6. So that's not going to help us a bunch. This one looks like -3. Does it cross at 0? It doesn't touch at 0. It's not this one. I know that from because it has to go through these. -3, 0, 3, and 6. So that helped me get one of them. Okay, so I'm going to go look at my graphing calculator. Another thing would be to look at your minimums and maximum points too, if you get really stuck. Because some of these look kind of close together. So when I go to my graphing calculator, the first thing I'm going to do is hit window. So I'm going to get out of this Poly Group Finder. I'm going to hit window. And remember that we wanted our window to be x minimum is -10, x maximum is +10, but I'm going to change my y minimum to -100 and my y maximum to +100. So my graph actually looks like what it should look like on the test. So y equals. From here, I can go straight to just type in whatever they have. So I've got x parentheses, x minus 3, x plus 3, and x minus 6. And then I'm going to go ahead and hit graph so I can kind of look at it. So that's what we're looking at. So to me, we said C was not it. I think it's pretty clear if you changed your screen what the right answer is, right? What is it? B. I mean, if you go and change those things, it's going to make your life easier. So B. Okay, 2 more for today. Graph the polynomial function. Okay, so if I want to use my graphing calculator on this one, and I want my screens to look like this, then that means that this -5 is going to have to be my X minimum. +5 is going to have to be my X maximum. My Y minimum is going to have to now change to -250. My Y maximum is going to have to be +250 for it to look like these. I do know that my leading coefficient, my leading term is 10x to the third. So one thing we know from that leading point test that we did on question number 1 and 2 is we know that it's positive and it's odd. So your endpoint, since it's odd, your endpoints are going 2 different directions. So it's not A, because those endpoints are both going up. And it's increasing. So it can't be this one. And I know it's increasing because it's a +10. So it's either got to be B or D. I know from that test. Okay. But this one is kind of tricky. Those look, B and D look very, very similar. So you got to be careful. Okay. So let's go to our graphing calculator. I'm going to my window. I'm going to mess with it first. My X minimum was -5. My X maximum was +5. -250 is my Y minimum. +250 is my Y maximum. I'm going to go to Y equals. I'm going to type in, let me go fix that. 10x to the third. -4 x squared minus 40 x plus 16. That should be better. Okay, we're going to look at our graph. Is that it? 10x to the third minus 4x squared minus 40x plus 16. Okay, and so here's what it looks like. Here's what I'm noticing. It's not going right through 0, 0. I do see that. So I don't think it's D, because D to me looks like it's going right through 0, 0. This other thing that I can do is look at this point right here and maybe find my relative maximum. So I can look at that. It's kind of hard to see. So I'm going to look at my maximum point, relative maximum, and calculate that. Pick something to the left. I'm going to pick something to the right of that maximum. And it tells me I've got a relative maximum at -142. So I'm kind of looking at that and eyeballing which one I think would be right from there. What do you guys think on that one? So -142, let me go back. So this point right here, -1, it needs to be at 42. Each one of these is going up by 50, so there's no way that that one's 42. It's not high enough. 42 is almost a 50. So it has to be B. So you're going to have to kind of slow down on these. Okay, this is the last one. Use synthetic division to determine whether the numbers are zeros of the polynomial function. So 2 things I will tell you. I can't tell whether you use synthetic division or not. Okay, so synthetic division is great, but that's not the only way to work this problem. If it is a 0, if -1 and 2 are zeros of this function, when you plug them in, what's the answer? 0. Okay, so one option would be to go to your graphing calculator and go Y equals and type in x to the fourth plus 2x to the third plus 2, all that stuff, right? And then look at your table and see if across from -1 is a 0 and across from 2 is 0, because if they're not zeros. If they are zeros. Okay, so that's one way to do this. Another way is to do what they're telling you to do, is use synthetic division. So I'm gonna see if, so I wrote down -1 here. 1, 2x to the third, 2x squared, -6, -7. Remember that you have to have one of these things for each power of x. So if there's not a, if there's, for instance, if there wasn't an x squared, I would have to put 0 for that place. So I'm gonna move my 1 down. 1 times -1, -1. 2 plus -1 is 1, times -1, -1. Adding these, 2 plus -1 is 1, times -1 is -1. -6 and -1 is -7, times -1 is 7. And I got 0 as a remainder, which means that yes, -1 is a 0. Then it wants me to do the same thing with 2. Is it even possible to have more than 1 0? Yeah, it's just where it crosses the x-axis. Yes, it can have more than 1 0. So we're going to see if this down here is a 0. So I'm bringing down 1 there. 1 times 2 is 2. 2 plus 2 is 4. 4 times 2 is 8. 2 and 8 is 10. 10 times 2, 20. I mean 16, sorry. 10 times 2 is 20. I don't know why I put 16. Okay, -6 and 20. 14. 14 times 2, 28. 28 and -7 is 21. Still no. Are y'all okay with that? Just make sure we got this one. Okay, so we're good. We will get the rest, there's 15 more. We'll get the rest of those on the next one.